So in our next part, we'll see some of the general solution and allied angles, which is useful for our further examples. Okay, so see here, in our general solution, we'll see. Okay, so in our general solution, first of all, we need to understand the allied angles. Okay, allied angles, what it is, the allied angles. So if we see allied angles, okay, so we want the allied angles here. For understanding allied angles, we need to know some of the basic concepts. Okay, so for allied angles, we'll start from here 0 degree. Again, we'll go for 90 degree, means pi by 2. Again, pi means 180 degree. Again, here we'll get 3 pi by 2 means 270, and which is equal to 0, which is equal to 2 pi. Okay, so that means 0 and 2 pi both are having same values. So what do we do here? So in our first quadrant, we know that all ratios from our trigonometric function all are positive. That means sine positive, cos, tan, cosec, sec, cot all are positive. Okay, so if we go to our second quadrant, in our second quadrant, we'll get the positive as a sine and cosec. Okay, sine and cosec, it is a positive. And when we go for the next quadrant, so in our third quadrant, we'll get the cot and tan, both are positive. And in our last quadrant, remaining one, we'll get the cos and sec. So these all are the identities which is positive in our fourth quadrant. Okay, so that means the remaining identities. So if I consider in our second quadrant, if sine and cosec both are positive, okay, so that means the remaining one, the leftover identities, all are negative. So which are the negative here in our second quadrant? Cot is remaining, which is negative. Tan is negative. After that, cos and sec all are remaining. All remaining are negative. That means we are taking only the positive identities. Okay, so we have to use these trigonometric identities where all these are positive. Okay, now here in our quadrant, we can see that for using allied angle, we have to use angles. Okay, so if we go through pi by 2 here, okay, if you go through the pi by 2, if you if we add some theta in our pi by 2, so obviously it goes to the next quadrant. So here we can see, so if I add pi by 2 plus theta, so here we can see pi by 2 plus theta, it goes to the next quadrant. Okay, and if you subtract some of the theta from it, so we'll get the pi by 2 minus theta. Okay, that means that small amount of a theta, if we can take it away from that pi by 2, so it goes to the previous quadrant. Okay, and if you add some, it goes to the next quadrant. Okay, similar that will be applicable for pi and 3 pi by 2 also. Okay, now for pi, how we do here? So if we add pi plus theta, okay, pi plus theta means next quadrant, and if we take theta away from there, so pi minus theta, so we'll get the pi minus theta. Okay, so pi minus theta, which is in a second, and pi plus theta in a third quadrant. Okay, similarly you can apply for 3 pi by 2 and 2 pi. Okay, so 2 pi minus theta, that means it goes to the down quadrant. Okay, in a fourth quadrant. So these all concepts are very much useful for our subsequent examples. Okay, so I hope you all have understood these basic concepts. I will explain all of these concepts in more detail, but at the timing of example. Okay, let's get started our examples. We'll see this property in our example. Okay, so we have our first example. Find the principal solution of a equation cot x, which is equal to negative of root 3. Okay, so here I have one suggestion for you all. So if you have the quantity like a cot x, cosec x, after that sec x, so you have to convert this quantity into sin x, cos x and tan x. Okay, that one will be the better for your calculations. Why it is better? Because we know that sine is having inverse ratio as a 1 upon cosec. Okay, similarly you can see for cos also 1 upon sec, and tan also 1 upon cot. Okay, so here we can see all our three trigonometric identities are having their inverse ratios. Okay, so you can see that here sine, which goes to 1 upon cosec. That means if you wanted to find the cosec x, so what do you have to do? Find out sine x. Okay, that means if you want this value for cot x, then find out 1 upon tan x. Okay, so these are the better calculation for our trigonometry. Okay, so at a time to remember all the results in a trigonometry, it's quite difficult. So what we do now, we convert first and then we'll solve. Okay, so now here we have cot x, which is equal to negative of root 3, and we want the principal solution. As we know that principal solution which lies between 0 to 2 pi but not including 2 pi. So we have to find out all the solution which lies between 0 to 2 pi interval. Okay, so here we have cot x. First of all, convert cot x into the tan x. It will be the better for our calculation. Okay, so we can write cot x as a 1 upon tan x, 1 upon tan x, and remaining term keep as it is, negative of root 3. Okay, so we want the tan x to finding the value for tan x. So what we do, just take the reciprocal from both of the sides. Okay, so we'll get the tan x, which is equal to negative of 1 by root 3. Okay, so reciprocal from here and as well other side. Okay, so I got the tan x as 1 by root 3. Now tell me, the students, which is the possible value for x which gives us a negative of 1 by root 3. Okay, negative means when we get the negative angle, when we go through the clockwise direction, then we get the negative angles, and when we go through the positive angles, that means anti-clockwise direction, we'll get the positive angles. Okay, so here we can see we have negative means we have here clockwise angle present here. Okay, so what we do, we use allied angle to convert that negative theta into positive theta. Okay, so when we have 1 by root 3 as the value for tan x, yes, it is when we take tan x as a pi by 6. So we'll get the 1 by root 3. Okay, so here we can write tan x, this step as a tan x, which is equal to negative of tan of pi by 6. Okay, so what I have done here, I replace 1 by root 3 as a tan of pi by 6. Okay, so this is the replacement 1 by root 3 as a tan of negative of tan pi by 6. Now we want the principal solution, and always remember principal solution always in a positive sign. So convert that negative to the positive, so you will get the positive sign. So we have negative of tan pi by 6. So I want that negative of tan pi by 6 into some positive theta. Okay, for finding that positive theta, we'll use allied angle. Okay, and now just remember the previous concept where we have tan negative. So we want negative tan to the positive. So search out where it is tan negative. Okay, and we know that tan it is positive only in a third quadrant. In a third quadrant, tan and cot it is positive. Okay, and in first quadrant everything is positive, so we don't have to worry about the first quadrant. Okay, so we have to go for the second and we have to go for the fourth. Okay, second quadrant will take the tan of pi minus theta. Okay, and for fourth quadrant we take tan of 2 pi minus theta. Okay, tan of pi minus theta, so pi minus theta means second quadrant, and in second quadrant tan it is completely negative. Okay, so we'll get the negative of tan theta, and tan of 2 pi minus theta, where it goes to fourth quadrant, and in our fourth quadrant only sec and cos both are positive, so that means tan it is negative of tan theta. Okay, I hope you all have understood these two allied angles that we are going to use here in our result. Okay, so now what do we have, negative of tan pi by 6 means negative of tan theta. Okay, so replace this value. So what we do, negative of tan pi by 6 can be written as tan of pi minus pi by 6. What I have done, replace the value of theta by pi by 6. Okay, so what we get here, tan of pi minus pi by 6. Okay, this one is our first result to find out the first principal solution. Okay, now what we get the next step, check it out. 6 pi minus pi, tan of 5 pi by 6. Okay, 6 pi minus pi, which is a 5 pi by 6. So we'll get the negative of tan pi by 6, negative of tan pi by 6, which is equal to tan of 5 pi by 6. So this one is our first theta that gives the us positive value. Okay, so we have 5 pi by 6, and which can be written as between of 0 to 2 pi. So if you wanted to verify if it is lying between 0 to 2 pi or not, so you have to check using its value. Put pi which is equal to 180 degree and verify it whether it is coming between 0 to 2 pi or not. Okay, and obviously it is there. So now let's go for the another term. Another term means we have to use another result here, okay, which is a tan of 2 pi minus theta, and which is a minus tan theta. Okay, so what we have, minus tan theta, which is equal to minus tan pi by 6. Okay, and we want minus tan pi by 6 as a tan 2 pi minus theta. That means tan of 2 pi minus pi by 6. Okay, minus theta means 2 pi minus pi by 6, it is there. Okay, so what we do, 2 pi into 6. So tan of 2 pi into 6 means 12 pi. 2 pi into 6 means 2 6 are 12. And pi it is there. 12 pi minus pi, which will get the 11 pi and completely divided by 6, and which is equivalent to, or which is equal to, tan of pi by 6. Okay, so these two values are equal. These two values are equal. Now here we can observe 11 pi by 6, which is also lies between 0 to 2 pi. Okay, between 0 and 2 pi. You may have to check this one whether it is lying there or not. Take value of a pi and calculate. Okay, so we get the 11 pi by 6, which lies between 0 to 2 pi. Okay, so we got the another theta. Okay, another theta, that means another principal solution which lies between 0 to 2 pi. Okay, so you may check is there any other solution possible or not. So surely it is not there, because we have only two allied angle possible for negative values. So that's why we got these two values. Okay, so if you're going to consider another allied angle, maybe you will get the wrong answers. Okay, that means negative answers are there, and allied in our principal solution we always consider positive thetas. Okay, so I hope you all have understood this theta and this one. Okay, this one and another theta, this one. Okay, so this is our required principal solution for our trigonometric identities. Okay, so which asked in March 2013 for 2 marks. Okay, I hope you all have understood. Now let's move for the another example. So in our next example we have principal solution. Okay, we want the principal solution for sec x, which is equal to 2 by root 3. Okay, and example asked in March 2018 for 2 marks. Okay, it's from March 2018, 2 marks. Very easy example. Now in my first example, what I have done, I converted cot into the tan. Okay, so and then we found the answer. But in this example we are not going for the conversion, we'll go for the sec x as a sec x. Okay, if you want to convert sec x into the cos x, you can go for cos x as a root 3 by 2. You will get the right answer. Okay, but already I explained that method, so I'm not going to continue that method here in our next example. In my next example I will explain this another method that you all can understand. Okay, that's why I'm taking sec x as a sec x. So sec x we have 2 by root 3, and tell me the when we have sec x is a 2 by root 3, when I consider sec x as, when we have 2 by root 3, I want the value for sec x as a 2 by root 3, and when we take x as a pi by 6, x as a pi by 6, then we will get the sec of pi by 6. When we take x as a pi by 6, we will get the sec of pi by 6 as a 2 by root 3. Okay, so we got the value for sec of pi by 6, which is a 2 by root 3. Now I hope you all have understood how it is coming. Okay, these all are the values from the table of trigonometric ratios. So here pi by 6, and we know that pi by 6 means which is a 30-degree angle, 30 degree which lies between 0 to 2 pi. Obviously it is there. Okay, that means we got the first solution which is between 0 to 2 pi. Okay, which is the first solution between 0 to 2 pi. So as we don't have negative angle, so we do not have to use allied angle for conversion. Okay, already whatever the first theta coming, we'll consider it as our first principal solution. Now for second principal solution, search where sec it is positive. We want the positive value for sec na, that's why we have to consider positive allied angle for sec. So what we take, sec of 2 pi minus theta. So if we use sec of 2 pi minus theta, means it is in fourth quadrant, there sec it is positive. If you go for second quadrant, sec it is negative. Third quadrant also negative. First quadrant it is positive. But in our first quadrant, in our first quadrant we got the pi by 6 here. So we already have one solution in our first quadrant. Okay, there is not for there we do not have any other chances that we will get the another theta in our first quadrant. Okay, so second quadrant sec it is negative, so we cannot check in our second quadrant. Third quadrant it is sec also negative, we are also not going for that. But in a fourth quadrant sec it is a positive. Okay, so we'll take sec minus sec of theta, we can write as sec of 2 pi minus theta. Okay, so I written sec theta as a sec 2 pi minus theta. Okay, so here we replace theta as a pi by 6. Now you may have one question here, why sir didn't take the value for pi by 2 or 3 pi by 2 as a allied angle? That means sec of pi by 2 minus theta, sec of 3 pi by 2 minus theta. So as we all know that if we use a pi by 2, 3 pi by 2 odd angle, that sine cos tan they get converted into the another one, tan get converted into the cot get converted into the tan. Okay, so that conversion we do not want here. Okay, that's why we didn't use this pi by 2 and 3 pi by 2. Okay, so we are taking only pi and 2 pi, just we do not want the conversion, that's why. Okay, so here we use sec of a theta as a sec of 2 pi minus theta. So one theta we have here pi by 6. Okay, so we will apply that theta here, then we will get the sec of pi by 6. Okay, we can write sec of 2 pi minus pi by 6. Okay, so here we have sec of 2 pi minus pi by 6. So go for the calculation. 6 to the 12 pi minus pi, we'll get the sec of 11 pi by 6. Okay, so we can write sec of pi by 6 as sec of 11 pi by 6. Okay, so that means both thetas are equal. Okay, both thetas are having equal values, and we can easily check that 11 pi divided by 6, which is lies between 0 to 2 pi. Okay, so we got the another solution which lies between 0 to 2 pi. Okay, see that how easy these examples are. So in our board exam, everywhere every year similar examples are coming. Okay, so that's why you don't have to forget these examples. Use these examples to make your score higher. Okay, so use that example asked in March 2080 for 2 marks. Okay, I hope you all have understood for the principal solution. Let's move for one more example. Okay, we want the principal solution for equation sin x which is equal to 1 by root 2, and that question asked in March 2020 for 2 marks. Very easy question that we just have to apply simple results. Okay, allied angle, I don't think so it is difficult here for you all. Okay, so sin x, tell me for what value of a sin x is having value 1 by root 2. Yes sir, it is there. It is a pi by 4 means 45 degree, and sin 45 gives us 1 by root 2. Okay, that means sin x can be written as sine of pi by 4 means 45 degree, and which is having value 1 by root 2. Okay, so we got the first theta as a pi by 4. Okay, and pi by 4 means 45 degree, and if can we say that pi by 4 which lies between 0 to 2 pi? Yes sir, we can say easily, because it is clearly there mentioned there pi by 4 lies between 0 to 2 pi. That means pi by 4 is having 45 degree value. Okay, so obviously it is there. Okay, I hope you all have understood that first theta. Now using first theta, let's move for the another second theta. Okay, find out the second theta. Now we want the sine theta where it is a positive. Okay, or apply that positive allied angle there to find out the next theta. Okay, now tell me where sine theta is a positive for our allied angle in quadrant wise. Okay, so we are not going to check in our first quadrant, because already we have pi by 4 1 theta in a first quadrant. Okay, we want the another theta in a second, third or fourth quadrant. Okay, between of these three quadrant. Okay, now we can see that if we use sine of pi minus theta, that means it goes to the second quadrant, and in second quadrant sine and cosec both are positive. Okay, we'll get the sine of theta. Okay, sine of pi minus theta, we're getting sine theta. Okay, now what we do, replace theta. Now check it out, is there any other allied angle possible where we get the sine positive? No, in our fourth quadrant sine it is negative, third also sign negative, so we cannot apply this quadrant. Okay, so we can apply only the second quadrant. Okay, and second quadrant it says that sine theta which is equal to sine pi minus theta. We cannot go for the pi by 2. If we go through the pi by 2, sine get converted into the another trigonometric identity, so we do not want that conversion. Okay, so be careful about this. So replace theta as a pi by 4, so we'll get the sine of pi minus pi by 4. Okay, so we'll get the sine of pi by 4. So I replace theta as a pi by 4. Now see that, go for the calculation. 4 pi minus pi, we'll get the 3 pi divided by 4. Sine of 3 pi by 4 is a sine of pi divided by 4. Okay, so here we easily can say that sine pi by 4 is having equal value with the sine 3 pi by 4. Now check it out, whether 3 pi by 4 which lies between 0 to 2 pi or not. Yeah, it is lies between 0 to 2 pi. We can easily say that. So we got the two separate principal solution which lies between 0 to 2 pi. Okay, between that interval. So we don't have any other principal solution that can come under 0 to 2 pi. Okay, so here our first solution, here it is our second solution, and principal solutions are having finite numbers of the solution. Okay, so we have to find out only one or two solution here. Okay, that one only belongs to principal solution. I hope you all have understood it very well. Okay, because principal solution, it is quite easy, just using one or two results from the allied angle. Okay, now let's move for the next example. We'll move for the general solution. Okay, so we'll see how the general solution we can find it easily. Okay, so here in our next example, we want the general solution. What we want? General solution for tan square x which is equal to 1. Okay, so before I begin my general solution examples, I wanted to make you all familiar with the sum of results from our general solution. Okay, now here we can see, if we use sine theta which is equal to 0, then how many theta it is possible? General solution means it is a generalized solution which we get using periodicity. That means after one period which theta possible, after that period which theta possible. There are infinitely many periods available. So using that periods, how can we find the general solution? That one we want here. Okay, so now let's see how can we find the general solution. I will explain with one short example. If we use general solution, then how generalized solutions are look like. Okay, now if I use a sine theta which is equal to 0, now tell me for how many values or what much values sine theta goes to 0. Okay, so if I consider sine 0, and we know that sine 0 always having value 0. So if I consider sine pi also having value 0. Can sine 2 pi also have sine 2 pi it is also having value 0? Yes sir, sine 2 pi also having value 0. Yes, 2 pi also gives the value 0. Again we go for the 3 pi, 4 pi, 5 pi and so on. Okay, we'll get the 3 pi, 4 pi and so on for all number of pi's. Okay, all n number of pi's, sine gives us a value 0. That means we can generalize one simple result here that can give us all sine where sine goes to 0. Okay, now here we can say, if we multiply 0 to pi, we'll get the 0. If we multiply 1 to pi, we'll get the pi. If we multiply 2 to the pi, we'll get the 2 pi. If we multiply 3 to the pi, we'll get the 3 pi. And if we multiply 4 to the pi, we'll get the 4 pi. Okay, that means that number goes to on and on. That means it goes to the infinitely many values. So how we denote this one as a general solution? We will take all these number as n. Okay, that means we can define sine theta which is equal to 0 as their general solution, theta which is equal to n number of pi, and n belongs to integer I. Okay, I denoted as the integer, or z also we can define it as the integer. Okay, I hope you all have understood this one. Okay, now let's move for our example. Okay, it is for the sine theta. When sine theta goes to 0, then theta which is equal to n pi. And when cos theta goes to 0, what we can define general solution? Yes, exactly. When we have pi by 2 and 3 pi by 2, when this on that axis, we will get the cos theta 0. That means pi by 2 and 3 pi by 2, sine cos goes to 0. That means odd number of values, cos goes to 0. And odd number of values, how can we define? 2n plus 1. So if you substitute the value for n, you will get the all odd values. Okay, for all odd number of values, we'll get the 1, 3, 5, 7, something like this. Okay, and we have to multiply pi by 2. Okay, so if you multiply pi by 2, we will get the pi by 2, 3 pi by 2, after that 5 pi by 2, like that n pi by 2. Okay, so 2n plus 1 pi by 2. So when we have cos theta which is equal to 0, this implies theta which is equal to 2n plus 1 pi by 2, and n belongs to integer I. Okay, I hope you all have understood this topic. Very much easier, just we have to apply the result from I. Okay, so this is for the cos theta, and similarly we can define it for tan theta. Okay, and when we have tan theta 0, so when we have tan theta 0, as sin theta is a numerator for cos theta, then we get the tan theta. So whenever sin theta is 0, there exists tan theta 0. That means if a tan theta is equal to 0, the result from sin theta we can apply as it is. So we'll get the theta which is equal to n pi. Okay, so we got the third result also. Okay, when sin theta 0, we get the theta which is equal to n pi. When we have cos theta 0, theta get the 2n plus 1 pi by 2. And when we have tan theta which is equal to 0, we'll get the theta also n pi. Similarly, we have to define that identity for sin theta which is equal to sin alpha, cos theta which is equal to cos alpha, tan theta which is equal to tan alpha. And one more thing is there, sin square theta which is equal to sin square alpha, cos square theta which is equal to cos square alpha, and tan square theta is equal to tan square alpha. When we have three of these square term, okay, so we will take it as the n pi plus minus alpha, and n belongs to I. Okay, all this this generalized result which is applicable for sin square theta which is equal to sin square alpha, cos square theta which is equal to cos square alpha, and tan square theta which is equal to tan square alpha. Okay, so when we have this square form of a trigonometric identities, then we'll get the one generalized result as a theta which is equal to n pi plus minus alpha. Okay, and that n goes to integer. Okay, so we are going to apply all these results in our general solution, then we'll go for the solution of these examples. Okay, I hope you all have understood that generalized solution part. Okay, so let's apply this part in our example. So let's get started. Okay, so here we have tan square theta which is equal to 1. Okay, that means tan square x which is equal to 1. In our trigonometry, we denote x and theta as their angle. Okay, so don't get confused, theta and x both are having same meaning. Okay, so here we can write tan square x as a 1 square. Can we write 1 square as 1? Yeah sir, we can write it is, because 1 square always contain the value 1. Okay, so we can write it is 1 square. So why I'm writing it is 1 square? Because we have one side tan square theta. So can it possible to bring out another side as a tan square? Yeah, surely it is possible. Okay, so we know that if we take a tan pi by 4, if we take a tan pi by 4, we'll get the value 1. Okay, so what is the value for tan pi by 4? You all need to know these basic values, okay, which is 1. Okay, so whenever we have tan pi by 4 1, so we can write tan pi by 4 bracket square. Okay, already square it is there. Okay, so one I kept as a tan pi by 4, and a bracket square it is there. Okay, and we know one more identity. So tan square theta which is equal to tan theta bracket square, both are having equal meaning. Don't get confused, because complete bracket square and that quantity square, it is having equal meaning in our trigonometric. Okay, so be sure about these calculations. Okay, now we have here tan, we can write this one is a tan square x which is equal to tan square of pi by 4. Okay, these two values are equal. Okay, that means tan square theta is equal to tan square alpha, then that time we'll take as a theta. Okay, so when we have tan square theta which is equal to tan square alpha, then we take theta which is equal to n pi plus minus alpha. Okay, so always remember that result we'll use for our calculation. Okay, so what we do, we have here theta as a x and alpha as a pi by 4. We have theta as a x and alpha as a pi by 4. You can see that values and substitute that value in our theta. So we'll get the x which is equal to n pi plus minus alpha, it is a pi by 4. Okay, so this is our required general solution. See that how easy solutions are these, just for 2 marks easily, 3 to 4 step you will get the 2 marks. So that how easy mathematics is. You just need to understand some of the basic concept, you will get the all of the solution quite easy steps. So quite easy steps. Okay, so I hope you all have understood this complete solution. Don't see that nothing is difficult here in our solution. Okay, so just what we done, we transfer another side as the form of a square, and then we apply directly the result for tan square theta, which is equal to tan square alpha. Okay, so I hope you all have understood. Let's move for the another example of general solution. Okay, so we have here next 4 cos square x, which is equal to 1. Okay, so adjust that term, because the term which is given, it not look like as a standard form of a trigonometric identities that we can consider the standard form, like a tan of pi by 4, tan of pi by 2, like this, cos of pi by 4. Okay, so for this, adjust first of all our trigonometric identities. So what we do, cos square x, which is equal to 1 by 4, we can write it is. Okay, so as we know that one side it is in the form of a cos square theta, so another try to transfer in the form of a cos square theta 2. Okay, okay, so what we do here, so cos square x can be written as 1 by 2 bracket square. Okay, and we know that as sine 30 having sine 30 is having value 1 by 2, so it opposite direction means cos 30, cos 60 gives us value 1 by 2. Okay, that means we can write cos of pi by 3. Cos pi by 3 means 60 degree now. Okay, so cos pi by 3 bracket square, which is equal to cos square of x. Okay, cos square of x, we get the cos pi by 3 bracket square, and as we know that cos pi by 3 complete square, which is equal to cos square of pi by 3. Okay, so how can we write cos square of pi by 3? Okay, so this way we can write this one. So cos square x, we got the cos square x, which is equal to cos square theta, which is equal to cos square alpha. Okay, so that means cos square theta, which is equal to cos square alpha. When we have this result, we write theta, which is equal to n pi plus minus alpha. Remember that one always. Okay, so n belongs to integer, so apply that theta in our result. So what we have here, we have theta as a x and alpha as a pi by 3. Put all these value in our theta, so we'll get the theta as a x. Okay, that means x, which is equal to n pi, keep as it is, plus minus alpha pi by 3. Okay, so this is our required general solution. Okay, I hope you all have understood. Okay, and n belongs to integer I. Okay, see that how easy that solution it is. Okay, nothing is difficult there. If you are going through proper steps, if you apply proper allied angles general solution, you will get the right answer. Okay, so I hope you all have understood. Let's move for the another example. Okay, so we have general solution of equation cos x plus sin x, which is equal to 1. Question asked in March 2013, and for it's for 3 marks. Okay, so what we do, we'll go for the first of all general extended form of our trigonometric identity, and then we'll find out the general solution. Now here we can see till the moment we got the example where one trigonometric identity is equal to some another identity, some specific value. But here at a time we have two identities together. Okay, like a sine and cos. In such a condition, what we do, first of all we try to expand this quantity in some fixed value of a sine or cos. Okay, so as we know that if we use cos of a minus b, cos of a minus b. Okay, so we know that cos of a minus b is having value cos plus sine sine. Okay, so if we have cos of a, cos of b plus sine of a, sine of b. Okay, that means cos plus sine sine, it is having value cos, and when it is having the plus, it is there, replace plus by minus and minus by plus. Okay, so we have cos of a minus b, which is equal to cos a cos b plus sine a sine b. So apply this result and try to transfer our trigonometric identity here. Okay, so we have to equate this one. So as we know that sine and cos both are having equal value at a 45 degree, that means pi by 4. So sine pi by 4, cos pi by 4, which is having 1 by root 2 value. So if you want that value together at our quantity like a cos x and sine x, so multiply 1 by root 2 throughout to our equation. Okay, so we'll get the next step 1 by root 2 cos x plus 1 by root 2 sine x which is equal to 1. Okay, and which 1 multiplied by 1 by root 2. What we have done, we multiplied 1 by root 2 throughout the steps. Okay, so 1 by root 2 we know that. So we have here cos x. Now we can see that cos one term it is there. We want the another term for cos. So one we can write cos of I by 4 as a 1 by root 2. Again cos of x plus sine of I by 4 into sine of x which is equal to 1 by root 2. Okay, don't do anything for that 1 by root 2, keep as it is. Okay, so we are going to consider that 1 by root 2 at the end of example. So cos a cos b plus sin a sin b. So as we have two terms, cos a cos b plus sin a sin b, we apply that result cos a minus b. Now select a and b very carefully where we want theta as only positive value. Okay, so we can consider a as a x and b as a pi by 4. Okay, that means we can write cos of x minus pi by 4. So most of you all are thinking, sir, why you have taken x minus pi by 4? Why it is not there pi by 4 minus x? Because if we want the general solution, that means we want the value for x. Okay, and if you want the value for x, we want that x in a positive. Okay, so negative we cannot consider. So if you want that one a positive, so that's why we are taking x as a positive value. Okay, so cos of x minus pi by 4 which is equal to 1 by root 2. So how can we write 1 by root 2 in the form of a cos? Yes, exactly. We use cos of pi by 4. So here we can see that we got the cos theta which is equal to cos alpha. And whenever we have cos theta which is equal to cos alpha, we use theta as 2n pi plus minus alpha. Okay, what we use? Theta 2n pi plus minus alpha when cos theta which is equal to cos alpha. In that situation we use theta is a 2n pi plus minus alpha. Okay, so apply that result here. So we have theta as a x minus pi by 4 and alpha as a pi by 4 only. Okay, so put both of the result in our standard form. So x minus pi by 4 which is equal to 2n pi plus minus pi by 4. Okay, so we got this one. So what we want here, we want the value for x, only the value for x. That means we want the only theta. That's why we what we do, we transfer that minus 4 to the other side. X which is equal to 2n pi plus minus pi by 4 plus pi by 4. Okay, so this is our required general solution. So if you want that solution for next step, so you go for plus sign add separately, minus sign add separately, you will get the two different solution for our theta. Okay, so we'll get the x as a 2n pi plus pi by 4 plus pi by 4, and second one x which is equal to 2n pi plus sorry, here we get the minus pi by 4 plus pi by 4. Okay, these are the two required general solutions. So here we can observe when we have two trigonometric identities, that time we get the two different general solutions. Okay, so I hope you all have understood that solution asked in March 2030 for 3 marks. Okay, let's move for the next question, tan 2x which is equal to 0. Okay, so when we have tan 2x which is equal to 0, so consider tan 2x which is equal to 0 here. Okay, so what we do, tan 2x is a 0, so try to transfer tan theta which is equal to tan alpha. So we'll get the tan 2x which is equal to tan of 0. Okay, so tan theta which is equal to tan alpha, and then when we have tan theta which is equal to tan alpha, then we use theta which is equal to n pi plus alpha. Okay, we use theta as a n pi plus alpha. So that means 2x which is equal to theta as a 2x, so n pi plus alpha is a 0. So we'll get the x which is equal to n pi, which is our required general solution, and n goes to integer I. Okay, I hope you all have understood that my complete solution. Okay, so that question asked in March 2020 for 3 marks. Okay, so this is our required general solution. This is our required general solution for tan theta which is equal to 0. Okay, I hope you all have understood my complete solution. So thank you everyone. Thank you for my today's lecture. I am expecting that you all have understood it completely. So thank you everyone.